welcome to the lesson on multiplying rational expressions. So today we're going to be covering one of the operations that are performed on rational expressions. So if you think about some of the lessons that we did in the past, basically this is a rational expression. You have a polynomial. This is a binomial over another binomial. And then all we're going to do today is basically just multiply it by another rational expression. These can look like anything that we've seen in the past as far as polynomials go. So let's just get started. Now, a little bit of a connection here. We can connect multiplying rational expressions to just how we used to multiply fractions. So if you think about how we would multiply fractions in the past, we have numerators and denominators. So just thinking about this a little bit differently than what you've probably done, what we want to do here is one of the steps that we're going to be doing is factoring all the numerators and denominators. So if you think about this, 10 factors into 5 times 2, 6 factors into a 3 times a 2, 9 factors into a 3 times a 3, and 35 factors into a 5 times a 7. Now, we could have very well just done 60 over 9 times 35, that big number, but this is actually a kind of better way to do this because then you don't have to work with larger numbers. You can simplify as you're multiplying along. Because now when we want to multiply, we basically just have to just multiply the top times the top and the bottom times the bottom. So we got our 5 times 2 and our 3 times 2 being multiplied together, 3 times 3 and a 5 times 7. Whatever's on top and bottom are one equivalencies, so you can go ahead and just cross those off. And once you cross off all the things they have in common on top and bottom, which were the 3's and the 5's, then you're basically done simplifying. And you're left with 2 times 2, which is a 4, and 3 times 7, which is 21. All right, so now to take this knowledge into the rational realm, couple steps here to remember. First step, just like we did in the previous example, is to basically factor all numerators and denominators. Then after we're done factoring everything, oh, by the way, this first step is probably going to take the longest part, just because if you remember, factoring polynomials can take a little bit. Second step goes by pretty fast. You just write it as a single rational expression, so that's the multiplication step. Once we start, quote unquote, canceling the ones that match on the top and the bottom, that's simplifying. And then we do still need to identify any restrictions that are on the domain. So whatever makes the denominator 0, we need to identify those because you're not allowed to divide by 0. So let's see what this looks like. So first example, so we got x minus 3 over 4x plus 20 times x plus 5 over x squared minus 9. So our first step is to factor all numerators and denominators. So I'm going to take a look at our two fractions. I'm going to go ahead and draw two fraction bars just so that I can kind of organize my thoughts. Now, x minus 3, it doesn't factor. It's a binomial. You should always check for GCF first, the greatest common factor. It doesn't have a greatest common factor. And it's just a linear binomial, so not really much else we can do with that one. So that one just stays the same. You do want to put it in parentheses because you want to think of it as a group. So if it's not factorable, go ahead and group it together. Same thing with the x plus 5. No GCF present. So that's about it for that. 4x plus 20. This one does have a GCF. So a little bit of side work here. If I want to factor 4x plus 20, I just find a common factor. So in this case, a 4 can come out of a 4x and a 20. So I'd pull a 4 out, and I'm left over with my x plus 5. Okay, so the 4x plus 20 factors into 4x plus 5. So that would go right down there. Last part, x squared minus 9. This one also factors. It's a binomial, but it is a squared. If you remember your shortcuts, x squared minus 9 is a difference of squares. So difference of squares pattern basically says that you find whatever is being squared for the front and the back, and then just do a plus and minus in between, and then that is that. I do want to show, if you don't remember this pattern, or actually, I won't show that part. So just try to memorize that pattern, and then we'll see how it works from there. Just pick up on those patterns when you see them, okay? All right, so next step. So we're done with the factoring step. So we factored all the numerators and denominators. Now we're moving on to step 2, which is write as a single rational expression All this really means is you put the top with the top, so the numerator with the numerator and the denominators with denominators. Pretty simple step, but that's basically you showing that you multiplied it together. So that's it for step two. Step three, we're going to start quote unquote canceling or finding one equivalencies. So just remember that you can only cancel groups at a time, just not a piece of a group. It has to be the whole group, or don't cancel that group. So x minus 3s is one of the first ones that I'm seeing. And then I got the group of x plus 5s is another one that I'm seeing. So all that's left on the bottom is a 4 and an x plus 3. Now on top, everything went away, but remember, it's technically there's still a number there, so I should write my 1. So you got 1 over 4 times x plus 3. Now the last step, identifying restrictions on domain. The important part about this step, you're not trying to figure out what makes your end answer 0. We got two denominators here at the very start. So you actually want to look at your beginning question, because a lot of stuff got canceled off here. So this is your simplified form, but what we want to look at is the question at the very beginning. What x values will mess this question up? Now, it's probably easiest to look at the factored forms to see what makes the denominators equal to 0. So just kind of shade out this work so you can kind of see what I'm looking at here. I got 3 different groups here. Let's see here. We got x plus 5. So if I think about this, negative 5 plus 5, that will make a 0. 4 times 0 will mess that up because that will make the denominator 0. Next group over, x plus 3. A negative 3 would make that one a 0, so we don't want a negative 3 there. And then the last group, a positive 3 minus 3 would make that one a 0. So our domain restrictions end up being negative x cannot be negative 5, negative 3, or 3. Right? And then your final answers are basically, this is what you get when you multiply and finish simplifying. It's 1 over 4x plus 3, 4 times the quantity x plus 3. And then these are your domain restrictions. Again, if you take a look at these numbers and you plug them into the very end, some of these numbers are okay because only negative 3 would make this part 0. But again, this was after we ended up canceling off some stuff. So you need to make sure that you look at the original equation up here. Factored form, again, is probably the best way to most easily see what would make the denominator 0. And then pull your domain restrictions from there. Okay? All right, so another example. So same steps. We're going to factor all the numerators and denominators first. So starting to set this up, I got one rational expression times another one. Take a look at the 10x minus 40 first. 10x minus 40, I can pull a 10 off of both of those. So let me slow down with that. So 10 times x is 10 times x, because I know I can pull a 10 out of a 40. If you want to prime factor these, you could do that as well. 10 could be a 5 and a 2, 40 is a 4 and a 10, 4 is a 2 and a 2, and then a 2 and a 10. So you can break it down to its prime factors and pull out one by one. But if you want to get faster with it, you want to try to figure out the largest number that can, the largest factor you can pull out of both of those, which would be a 10. And then you get leftovers go in a group, so 10 times x minus 4. So that ends up being the very first one. So you're kind of thinking of these as 4 little mini problems. So you're factoring this first numerator. That's like a little mini problem in of itself. Then you're going to factor this other numerator. You're going to factor this denominator. And then you're going to factor this denominator. So like I said, it's 4 little mini factoring problems inside of this one. So x plus 3, again, first look for GCF. I don't see GCF. It's not a difference of squares because x isn't even being squared. And then that's all we've really done as far as binomials, as far as factoring goes. So that one doesn't factor. That just turns into x plus 3. Make sure you group it together. Okay, trinomial. Notice our side work got a little bit bigger there, only because that trinomial piece is going to be a little bit more work we got to show here, depending on what you remember about shortcuts that we learned. So we're going to start with this x thing. You're going to multiply the front and the back. So the front has a little 1 up here as a coefficient. So 1 times 8, it goes up top. Negative 6, our middle term, goes on the bottom. So your goal right now is to figure out 2 numbers that multiply to be the 8, but add up to be negative 6. So think about it, and you get a negative 2 and a negative 4. So you break those up, and you get negative 2x, negative 4x makes that negative 6x. Now you're going to do a factor by grouping step. So you can pull out an x out of those two. For the second group, I know that I need an x minus 2 for this factor by grouping to work, so I'm going to go ahead and just write an x minus 2 over here. So I just got to figure out this number out front. What number out front would give me 4x plus 8 if I multiplied it to this? Must be a negative 4. Negative 4 times x, negative 4 times negative 2. Okay, pull out the common group, because I got a common group of x minus 2's, so those come out. Oops. Okay. And our leftovers go back in, so x minus 4. So this x squared minus 6x plus 8 factors down to this. Now, if you remember, if you have a value of 1 up front, you don't have to do all this factor by grouping. You could have just done this x part to split it up, and then you actually have your factored form here. Remember, that only works if there's no a in front. This is the longer way of doing it, but the longer way always works. So it's not a bad thing to always do something that works. So you got an x minus 2 and an x minus 4 for that first denominator. And our last one to factor out is 5x plus 15. So the 5x plus 15, breaking that down, look for GCF first. There is a GCF, sorry. So 5s, you can pull a 5 out of both of those. So 5 comes out, your leftover is x plus 3, and that is done being factored. Okay. Normally at this point, I would ask the class if you have any questions. You probably do. Feel free to stop by during my office hours, and I'll post those on the bulletin board so you know when to stop by. But for now, if you have any questions, just write them down so you can ask me later. Or look at some of those other resources that I put online. Other videos might help out as well. Okay? So now we're going to write this as a single rational expression. So this is the multiplication step. So it's telling me to multiply these two. So multiplying them is nothing more than writing it as one big thing being multiplied across the top and across the bottom. Now, if you notice, the denominator here looks a little different than the denominator down here. Because it's being multiplied, and because I know that I like having my monomials, like this 5, to be out front, like this 10 is, I can move them around. So I'm just moving this 5 to the front, and then all the groups to the right. Okay? So any groups, you should probably write them to the right, monomials out front. That way it's easier for you to spot which stuff simplifies out. Okay, so now we're going to start canceling or simplifying. So the x minus 4s, two groups that match up. X plus 3s are two groups that match up. So I ended up with a 10 over 5x minus 2. Now, if you notice this monomial, this 10 and this 5, if you think about this like a regular old fraction, if you just saw 10 over 5, you'd be able to simplify it. So I could actually do stuff with these two. I can't do anything with this group because there's no other whole groups for it to mess around with. So it's just the 5 and the 10. So 5 goes into 10 two times. You can think of this as a 5 times a 2, and the 5s go away, so you're just with the 2. Now, a little comment here. Remember, this 2 is part of this group, so don't start crossing these off, okay? Technically, you're done, and you can just write it like this, and you can leave the parentheses on so that you can see this as an entire group. But normally, if there's no coefficient in the front, you go ahead and take the grouping symbols off because the division bar works like it's a grouping symbol. So you just write it like this, and you still cannot cross these two off because technically this is still part of a group. Okay, and that's how you do that. Now we're not done yet. We still got step number 4. Identify restrictions on the domain. So again, we are done here. Now we want to go back to the very beginning and take a look at what would make these two denominators into 0. The easiest way to see that is by looking at the factored form. So we got to find out the things that x cannot be equal to. So it's going to be these 3 things that will tell us what will turn this into zeros. So basically a 2. If I plug a 2 in here, 2 minus 2 is a 0. That's not a good thing. Next thing is a 4. 4 minus 4 is a 0. That is not a good thing, so we say x can't be that. And the last domain restriction will be a -3 because -3 plus 3 would be a 0. Okay, And that is our domain restrictions. Okay, so this last part, I do want to show you kind of outside of the PowerPoint, just so you can see how you could structure your work. Because sometimes with the PowerPoint, I'm doing it on the PowerPoint and you can't really figure out like how much room this is supposed to take. So let me see if I can do this correctly. Okay. And no, it's not working. Oh, there it goes. Okay. All right. So, it's like a QuickTime recording inside a QuickTime recording. It's like an Inception kind of stuff. But all right. So, we got. Whoa. Oh, see, I messed this up now. I got two rational expressions. So one way that I will allow you to show your work is just by kind of looking at each of these. So if I look at the x plus 1, first step is to factor. So x plus 1, that just stays in x plus 1. So I can just factor it right above there. Okay. 6x plus 12. So I got a 6x plus 12. If it's just a small factorization like this one, you can just pull your work just right on top of it. So if I think of a 6x and a 12, what's my biggest factor that goes into 6 and 12, 6x and 12? That's probably going to be a 6. Then I have an x plus 2. 6 times x is 6x. 6 times 2 is a 12, so that's that factorization. And hopefully I have enough colors for this. Nope, that's green again. I used green already. Used red already. Ha! Blue. Blue will work. So we got 3x plus 6. What can I pull out of a 3x? Whoops, hands in the way. 3x and a 6. That can pull out a 3. I get an x plus 2 left over. 3 times x is 3x. 3 times 2 is a 6. So that's that factored form. Okay, the last one. I got 4 colors. Yes, 4 parts. So x squared minus 1. This is a perfect square because x times x is x squared. This is a perfect square because 1 times 1 is a 1, and I see a minus sign here. So I know this is a difference of squares. So this thing just factors into x plus 1 and an x minus 1. Okay, so that's the first step. Let's see if my arrow actually moves. Ooh, my doggy's mad at something. See, he noticed some of you not doing math, so my dog's barking in the background. Okay. Oh, end of slideshow. Oh, I didn't even finish with the arrow. Oh, well. Okay. So let me fix this. Okay, so the next part that we're going to be doing is going to be the write as a single rational expression. So I'm going to move this up some. So this is equal to, now I'm just going to take all my pieces and put them next to each other. Keep in mind this monomial, this 6, I want to pull out front just so that it's easier for me to see it. And then got an x plus 1 and an x plus 2. So those are all my numerators just placed side by side into one fraction, one rational expression. This one, the monomial of 3 is already out front, so I'm just going to write the 3 there. I got my x plus 2, I got my x plus 1, and I got my x minus 1. Okay. Now, if you remember domain restrictions, the factored form is the one that we kind of want to look at to know what the restrictions are. Yeah, restrictions are going to be, we should just look at this step before we start canceling. So actually it's a little bit out of order because I had said do that at the very end. But Mr. Aguirre is not really going to be able to tell which steps you did first or second. So let's go ahead and do that right now. That way it's easier to see before we start crossing stuff off. So x cannot be, and if I look at this, x plus 2, what would make this a 0? A negative 2, so x cannot be a negative 2. What would make this a 0? A negative 1 plus 1 would make this into 0, which would not be good because 0 times anything turns this whole thing to 0. So it cannot be a negative 1. And this last one is a negative 1, so a positive 1. So you got 3 different values that your domain cannot be. So if you plug these 3 values into the very beginning, that would zero out your denominators, and then basically most math people that know what they're talking about will look at you with a strange look on their face. So don't get people looking at you strangely. All right, so if we're looking at this, figure out what matches up. So I see my x plus 2's. Those ones are a 1, so they're gone. X plus 1 is a 1, so that's gone. And that's it. Nothing else really matches up. Now, if you want to, you can go ahead and simplify this part too. What I was talking about before is that you can technically factor the 6 into a 3 times a 2, because that's what 6 is, 3 times a 2, and then it's a little bit more clear why these go away. See, my dog Dexter agrees with me. He's like, yep, that's right. So 2x minus 1, and that's it. So you have this. This is technically right, but again, if you don't have a coefficient out front, like if you had a 5 out front, you should write the 5 and leave this as a group. But if there's nothing out, or technically there's a 1, but if you don't see a coefficient out front, you should just take the grouping symbols off and be done with it. So 2 over x minus 1. I probably wouldn't deduct points if you left it like this, but try to make sure that you know that these two are the same things in case you see it on a state test or anything like that. Okay? And again, if you have any questions or confused about any of this, feel free to stop by my office hours, and then I can try to clarify for you. Okay? Let me see if I know how to stop this recording now.